Hello, this is Mr. Fay. Today we're going to run you through some phase changes for the states of matter. You'll notice on the page, the bottom of the page is cold. And as you go this way on the page, temperatures get colder and colder and colder. And this way on the page, we're going to say that this is hot. So as you go this way on the page, you're getting hotter and hotter and hotter. Now, of our three stages of matter that we have, solids, liquids, and gases, we're going to say that solid is associated with the coldest temperatures, while gases are associated with the highest temperatures. And if you think of something like liquid water, this actually makes a good deal of sense. For example, water at a medium temperature, we'll say, or room temperature is a liquid. And if you drop that temperature enough to its freezing point, it will become a solid, which would be ice. Likewise, you can do exactly the opposite. You can take liquid water at a medium temperature or room temperature. You can heat it, heat it, heat it to reach a point where it becomes a gas at its boiling point. Now, with water, this is relatively easy, but you need to realize it happens with a lot of substances. And we can make it very simple and oversimplify it a bit, but we could say, like, let's take a rock. A rock is solid at, let's say, normal temperatures, even though it's next to the word cold. But if you raise the temperature of that rock high enough, you can get that rock to melt. Now, some people are like, what do you mean, a liquid rock? Well, sure. I mean, the Earth has liquid rocks in it. Temperature's high enough where solid rocks can exist as a liquid. Okay, magma if they're inside the Earth, lava if they're outside of a volcano. Likewise, you can also take that liquid rock, that lava or magma, and you could heat it all the way where it becomes a gas. For example, if you were to bring some lava to the sun and drop it on the surface of the sun, that would vaporize and become a gas. So it's true not just for things like water, but also other big solid objects like rocks. We can take a look at one more example, like, let's say, a gas. Like, let's look at O2, or oxygen. Oxygen exists as a gas normally, but if you cool it, and we're going to go over our green line here, if you cool it enough, you can get that to become liquid oxygen. Now, this is something that you probably already have some familiarity with. You might say, like, you can't have liquid oxygen. Sure you can. If you've ever seen anyone who carries an oxygen tank around and you shake it, there's liquid oxygen inside that tank. So you can have liquid oxygen. Now, they don't necessarily cool it to make it a liquid. They actually pressurize it, which is something we'll get into a little bit later. Likewise, you can continue to cool that liquid oxygen all the way down to solid. And you can, believe it or not, have solid oxygen. For example, the booster rockets on an Atlas V rocket or on the space shuttle, those two little white rockets on the outside of the space shuttle are actually SRBs, or solid rocket boosters, and they are filled with solid oxygen. So these are things that actually can and do exist. All right, we're going to take a look just quickly and name the processes as you go back and forth between a solid, liquid, and gas. First process we're going to look at is when you go from a solid to a liquid. So we're going to look right here, and this is known as melting. And melting is something that you probably already know. If you have an ice cube, and that ice cube turns into a liquid water, then you are going to consider that melting. If you had an ice cream cone, you'd say, hey, my solid ice cream cone just turned into a liquid. In other words, it melted. Likewise, you can go the other way. You can take a liquid, such as water, and if you cool it enough, you can freeze it. And when you freeze it, it becomes a solid. So these two processes here are kind of opposite of one another. We got a solid going into a liquid, which is melting, and then a liquid going into a solid, which would be considered freezing. Same relationship's going on up here. If you take a liquid and you heat it, and we have a few other words we're going to use for this here too, but as you take a liquid and you heat it, you can call that evaporation. Like a liquid puddle on the street may evaporate into water vapor because of the heat of the sun. Or you can put a pot of water on the stove and you can have it boil, so you can call it boiling. And some scientists will actually call it, you may hear this a little bit, you can call it vaporization. That's another one. I think I may have used that word possibly earlier today. So again, that's a need to know. This one right here might be a nice to know. Likewise, we can come down this way. This one is the one that most people find the most difficult of these. As gas turns back into a liquid, that is known as condensation. We got lots of examples of condensation. Anytime you cool water vapor, you can make a liquid come out. For example, water vapor in the atmosphere may condense to form clouds or water droplets, which can eventually turn into rain. Also, if you take like a cold can of soda out of the fridge, set it on the table, it will cool the water vapor that's already in the air and possibly cause condensation to form on the outside of that can. All right, just a quick extra note. There are some substances that can go all the way from a solid to a gas without passing through the liquid phase. Okay, so this leaves the liquid phase out of the equation. A great example would be dry ice. Dry ice is solid CO2 at a very cold temperature. And the reason why it's dry is because as you heat it and it melts in your hand, it actually ends up skipping the liquid phase. So you don't see any liquid come off it. It simply sublimates. Undergoes a process of sublimation, which means it will go directly into a gas. So therefore, you don't see any liquid coming off it whatsoever. They'll use it in fog machines sometimes, or in witch's brew, and you'll see them stirring it, and you'll see this gas hanging out along the top of the liquid that makes billow over the sides. Very often, that is dry ice, which is solid CO2. Just on one more note, might as well throw at you, there are other states of matter out there looming. For example, a superheated gas can actually turn into plasma. And plasma is another state of matter elevated beyond a gas that will actually start to emit light. So you'll see this in stars where you have incredibly high temperatures, but you can also see it in neon bulbs and fluorescent lights where you run an electrical current through a gas that's inside of glass. And as you do that, it will cause some of the atoms to become excited and release energy, the light energy, as they pass into that plasma state. Also seen with plasma TVs and stuff like that. So some very cool technology, but this right here is also something that would be nice to know, not necessarily a need to know. All right, this is Mr. Fay. I'm going to say goodbye. Hopefully that helped. See ya.